Well, hi, good morning. Thank you so much for coming and spending part of your day with me in my shop here. Today is March 24th. Kind of a gray day here. So just before I get going, I just want to thank you as a viewer. If you're one of the people who clicks the like button on the video or sends me encouraging emails or helpful emails, I want to thank you very much for that. That encouragement is important to me. So I do keep an eye on the number of likes that are occurring in the like-dislike ratio. Maybe I shouldn't, but I do. And it's encouraging to me when I see people clicking the like button. So thank you very much for that. Now this is day 2 on this radio. Yesterday I kind of got through the real simple stuff that had to be done just so I could plug the radio in and turn it on. And the result of operating it was it doesn't work. it didn't work at all. There's literally no sound coming out of the speaker. I didn't stick my ear up against it, but I think if I did, I wouldn't have heard anything. So I also noticed that the Magic Eye here was not varying at all. No bands varied it or anything. So there's a couple possible causes, many more than a couple possible causes, but a couple of primary causes for this would be a dead output tube. The tube here was glowing on this tube. That's one possibility. That wouldn't explain this though. Another possibility is no B plus in the radio. And I suspect right now that's really what's going on. There's no high voltage. None of the tubes are operating. Might have trouble explaining why you could see this one glowing if there's no B plus. I think you need B plus to make this glow. But that's where I want to start. I want to start today with measuring the B plus in the radio, and then maybe proceed to tube testing and eliminate that as a problem or correct it if there's some dead tubes in here. So B plus, the easy place to pick up B plus. There's probably an easy place on the top here to check it. I just as soon avoid turning this radio up on its end because that's a risky place for it to be. So I'm just going to stop right away and look at the schematic a little bit and see if I can't spot a place I could just put my voltmeter on and read the B plus voltage in the radio. Okay, and that means I have to get the schematic. Oh, I have the schematic for this specific radio. Sure I do. I'll show it to you. Okay, so it's a large schematic. It goes over a couple of pages here, so we're going to have to look at a couple of pages. I'm not going to run through the schematic and talk about all the stuff that's in it. I'll do that probably later on. Right now, I think what would be wise is for me to focus on the B plus question and read all the notes on the schematic. Now, the last radio I did was not a German radio, just a North American radio. I did not avail myself of the service manual till late in working on the radio, because often it's around alignment time that I really start studying the schematic carefully. Had I looked at it more carefully, I would have seen some notes that would have been good to have had in my head right at the start. So I don't want that to happen with this one now. So we're just going to read these notes, which may or may not be important, but only one way to find out. All push buttons shown in released or off position. Okay. DC voltage measurements taken with a vacuum tube voltmeter. AC voltage is measured with 1,000 ohm per volt voltmeter. So this is telling me that if I attempt to read the voltages that are listed, and I use my vacuum tube voltmeter I have here, I should read the same voltages as are listed on the schematic here and there. Okay, socket connections are shown as bottom views. That's important to know so you know how to number them, and you can relate them to the real radio. Measured values are from socket pin to common ground. Common ground. Now, does that mean the chassis? Common ground? Probably yes. Probably yes. Line voltage maintained at 117 volts for voltage readings. You know, when I'm doing these voltage readings, a variation of 10, even 15% doesn't concern me too much. So even if this isn't exactly 117, unless there's something critical going on, I don't worry too much about that. But generally, I run the radios a little less than 117 when I'm working on them. Nominal tolerance on component values makes possible a variation of 15% in voltage and resistance readings. Well, there you are, 15%. Volume control at maximum, no signal applied for voltage measurements. Must be a voltage table somewhere. Here's a resistance table. Maybe it's not a table, but the voltages are scattered. Yeah, scattered through the schematic. So I can find them. Let's take a look at these plate voltages. So what's the highest one? 190, probably on the output tubes. This one's much lower, 100. That's on the ECCC 85, which is somewhat inaccessible anyway. I'm hoping that this tuner is essentially identical to the tuner in the last Nordmende I'm not quite finished with yet because of trouble in the FM side of things. So I'm really hoping this radio is identical. It looks identical. Okay, there's a switch diagram, terminal board. I think this is on top of the output transformer. They're showing here 6 terminals. I'm just going to count them quickly. Oh, it doesn't match. 1, 2, 3, 4, 5, 6, 7. Okay, I'm not quite sure what they're showing there. Terminal board view T2. Oh, they name what it is. T2. Okay, that'll come clearer later. Another thing I'm a little bit concerned about is this exactly the right schematic? Some of these radios have multiple chassis, multiple versions. That probably means they made the same radio basically for years and kept making improvements as they released successive models, probably incorporating newer components, newer tubes, and other opportunities they have to make a better radio. Here's some more voltages. 220, 220. The detector. It looks very similar to the other radio. Here's some more of these terminal diagrams. Okay. Plug and socket view of solo and speech switch connecting cable. Solo and speech switch connecting cable. I'm not too sure what they're talking about there. Numbers assigned to coil switches, plug sockets, and transformers are to facilitate circuit tracing or component replacement. It may not necessarily be found on the unit. So I've already noticed that the numbers that are written on the board don't seem to match the numbers on this schematic. And this schematic did not come from Nordmende, I believe. This was made by, and we're not going to find the name of it here, are we? Sam's. I think it's a Sam's. Literally, I believe that Sam's got the radio and looked at it and produced this schematic, I think. Not quite sure about that. Here's the rest of the table over here. Resistance table. Here's the power supply. So here we are. So 265 volts is the maximum voltage in the radio. To tap on primary T2, lug 4. T2 is probably the output transformer. Here's T2. Yeah, output transformer to the speaker here. 255 from 265. So as usual on the output tube, they want to put the highest B plus to make this tube work as hard as possible. Produce as much, deliver as much power as possible into this transformer, because that's where power is needed to power the speaker. So we could look for it on the EL84 and see if it's all there. It's probably accessible somewhere. Well, it's accessible on this pin number 1 of T2 output transformer. Maybe we'll look for it there. I don't really have to figure out which pin is which. I just need to test every terminal, and one of them is going to show up with 255 volts. Like this one here is also, it's going to have actually more. It's going to have 265. So 265, 255, and 10 volts dropping through here. take notes now. Numbers, yeah. 48 watts, 52 watts in FM. Voltage selection. This has got to be powering all of the tubes. Look at that. A 1.5 inch length of number 32 wire. So that must be that little wire I saw on the back when I was looking at it. It says 0.2 copper. This says number 32 wire. I don't know if they're the same thing. I think they probably are, though. It's kind of in an odd spot. It's right near the output tube. I'm not sure why I think that's odd, but I do. See parts list for alternate value or application. This is some kind of note here. Some odd symbol I've never seen before. That occurs somewhere up here. You can see this little symbol here. I know from the other radio this means this is the, well, FM or AM. Like one of these is the AM and the other is the FM. The other radio, this was the AM. This little half moon symbol. DC coil resistance values under 1 ohm not shown. Arrows on controls indicate clockwise rotation. Control viewed from shaft end. Okay, I don't have to remember this stuff. I just kind of have to know there's notes on these topics, and I can always refer to them later. It's only a 2-pager. Only a 2-pager. Let's just see. C39, I think this is cut sharply on the edge. I don't think there's an overlap. Yeah. R8, let's go back. Yeah, there's this circle for R8 right there, so I think it's just a 2-pager. And what are the rest of these? Alignment instructions. A diagram showing the part location. I've already been utilizing these. Parts list based on the numbers used on this schematic, not on the actual machine, and more of this. These numbers refer to information contained in this document. What's this? This doesn't exist on this radio. So that's an additional set of tone controls, because engineers love the tone controls. And I think that's what this is. Because some radios must have this. And that makes me a little worried that just maybe this schematic doesn't actually fit the radio I've got. There's chassis numbers and stuff like that. I've always found it difficult to look at those numbers and relate them. But maybe I'll have to do that in the end. But for now, okay, so the issue right now is where to find B+ on the top side of the radio. And I was thinking at the output tube down here, top of this transformer. It's worth doing it at the transformer. There's always a chance the primary is burned open on the transformer, which would be a bad thing. You should find that out right away. So maybe this is a good spot to go and take a test. And just test all the terminals. There's a lot more than 4 on top of it. There's many more. Hey, let's look at the diagram. Just see if it says something about that. Where is that transformer? Where is it? There it is. It's. I have to look at the radio to sort it out. It's way over here. You know what? It's on a little. The board ends, and then there's an attachment to it out like this with the transformer on it. That's quite common in these radios. Maybe that's how they accommodated differences in radio models, that this core part was identical for a number of models, but then the output transformer was different from model to model, something like that. Maybe, I don't know, just taking a guess here. That's not going to help. Well, they're not really showing it. The output transformer. Let me look again just to be sure what I'm seeing. So So this wheel is attached to a metal frame, and the metal frame has the transformer on it. Doesn't look the same. Does not look the same. What have they done with the output transformer? Is it under here? No. Okay, not helping. But still, the basic rule that the high voltage is passing through the transformer so it should be findable on one of those terminals. Two of those terminals. At least two of the terminals. Okay, that's enough. That's enough of that. Okay, let's do this. Here's the VTVM vacuum tube voltmeter. And the big deal about the vacuum tube voltmeter is, in its day, it was the high impedance meter. Today we have electronic multimeters. They're also very high impedance. So the vacuum tube voltmeter does not stand out anymore as a piece of test equipment. But I like using it because I like the pointer. I don't like the numbers jumping around on the digital meters. Okay, we'll stick this on a ground point. It's plugged in. I'm going to practice a little bit here, just not that I need too much practice on this. Here's the output transformer. Terminals down this side, terminals down that side. Lots of terminals. Are they all involved with the transformer? They may not be. Maybe this is just, I don't know, maybe it's a terminal point that they put some stuff on it. These resistors here. This looks like 3 orange. This could be 3 orange. It could be 2 orange and a red, or 2 red and an orange rather. This one could be 2 red and an orange. Why don't we look for these on the schematic? Let's take a look for those. I'm going to go back to the schematic here. Okay. Here we are. So we're looking for, there's really nothing right in here. So orange, orange, orange would be 33K. There's just nothing like that here. Oh, there's one. 33K. There's one. There's another 33K. And then what might be a 22K? 33. I don't know. That's on the wrong side of the tube. Down here. It's just more indications that I don't have really the correct schematic, I think. I think that's what it's saying. Oh, another thing is this radio, I'm sure, had 2 speakers in it at one time. Speaker 2, 3, 4. Electrostatic. What? Wait a minute, were there more speakers in here? Because there's side panels for the speakers to put sound through, and I'm looking, and I don't think there was ever any speakers on the sides. I think there was just one tweeter in the front, so more indications I haven't got the right schematic. So, you know, if it's not the right schematic, this could be wrong, but it's going to be in the range of 265. It's not going to be much different than that. Okie doke. There's a different voltages. I'm not quite sure what this is here. Lug 3. Okay, not helping. Let's do the test. Okay, so we're going to turn the radio on. Now, you know, if there's no B plus and there's some reason for it, that reason could be getting hot. Well, I don't know though. Didn't notice anything yesterday. We'll put it on broadcast here. There we go. You kind of missed it, but the dim bulbs jumped up and went down pretty quick. That's a good sign. This is the big filter capacitor. It's probably okay. Unlike other filter capacitors, especially those cardboard ones you get in the cheap table radios, they're almost always shot. There's the magic eye is on, which suggests there's B+. Okay, we're going to give it the full Monty. I didn't give it full voltage yesterday, So maybe it didn't work because of that. I hear it. Did I hear it yesterday? Okay, B plus. Kind of dragging the pointer around. B plus, broadcast band. Ho, 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 ho. Ho, ho, ho. Well, I don't think we need to worry about B plus because you wouldn't hear that sound if it. Why are you not happy enough to produce? So I think we might have a tube problem, really. Because we can see the magic eye here. Let's take a look at what the voltages are. Okay, we're running at 114. That's slightly below the voltage they asked for. Call for. I'll try not to get my arm in front of the meter while I'm doing this. Who's got the high voltage? Where's my hand going? I'm going to steady it on this plastic cover here because this is painful. There's something. Okay, I'm on the 500 volt scale. It's 260 volts. Jumping around. Why? Because of me? Yeah, I think it's just, yeah. It's exactly on my meter. Check the zero here. Let's just make sure. I was fooling with it the other day. Get it zeroed properly. So that would be 270. Whoa, 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 whoa. 270. A little lower. 265, I would say. That's a ground. On the other side of this, this is going to the speaker. If I found 260 volts there, that would be a problem. 270. I mean, there's lots of voltage here. Lots of voltage everywhere. So I wonder if this is like a distribution point for the power supply. The big transformers at the other end of the radio. But, well, lots of voltage around. What about this thing here? Do you get it? Oh my gosh, look at that. Phew. Oh, you can't see what I'm doing, for crying out loud. So this is that fuse link system around. Fusible link, or I don't know what to call this. And right at this thing here, which is so easy to get into contact with your hand or something like that, 200, it's less, 245 volts, but wow, danger, danger, danger. This whole thing is dangerous here. In my imagination, or is the radio's volume changing a bit? This is plugged into an isolation transformer. I am wearing rubber-soled shoes. I'm standing on a rubber mat, which is on a ceramic tiled floor, which is on concrete in my basement. So if you're wondering, gee, touch that stuff? Can you touch that? There shouldn't be any danger in touching this. But I would never, ever risk myself by knowing that I'm grounded in some way and then touching anything in here. Never, 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 never. I try to make sure I'm never grounded. How do you get grounded? You get down on your hands and knees sometimes. You want to look at an angle, so you get down on your hands and knees. Your knees might ground. But again, I'm on a rubber mat. So. Funny, it won't receive anything. Where are we? We're at the wrong end of the dial. Let's just... There's lots of volume, which indicates week 2. Okay, we have no idea where we're tuned here. Go on, we're tuned here. There's the end of the road. Didn't hear a thing. It's just possible the antenna is aimed in a bad way. But there's all kinds of noise and interference that normally comes roaring through a radio. So I think what we're getting here is a bad tube message. The string is showing some signs of wear. A little bit of wear. A little bit. Okay, it's tube testing. Ooh. I haven't even pulled out the tubes and reseated them, which can sometimes solve these kinds of problems, but I did wiggle them yesterday. Okay, we're off for a round of tube testing. Okay, I'll get ready for that. I thought I'd start with the output tube, and it has a number I've never heard before, ECLL 800. So I decided to investigate that. I can't find any settings for my tube testers, any reference to it, related to my old tube testers. The tube testers I have were all built long before this tube existed. This must be one of the later, or towards the end of the tube era tubes. So, I didn't notice that. A 6KH8. What are the chances I have something like that? There's a chance, but it's very low, a low chance. So ECL 800, here's the thing about it. This tube is jam-packed. Look what's in there. It's got a triode. It's got two pentodes. I think these are pentodes. And I think these are I forgot the term. Beamed. I think they're beamed power tubes. Oh my gosh. That's a lot in one tube. So the idea is this one tube comes with its own preamp and then two power amps to do push-pull for a single speaker out of it. Wow, I'm going to have to look long and hard to try to find settings to test this tube. Does it say when it was first introduced? I think sometimes they write that in here. Novel 9-pin miniature. Did they give a date? What? April 2003. That's some guy making comments. So I did read somewhere that these can be replaced with two EL95s, but yeah, right. You have to redesign the radio to do that. Well, I don't have any reason to believe this tube is bad at this point. No more information here. People talking German. Yeah, okay. ECLL 800. Not going to get tested here for now. The test will be whether it works in the radio. We did hear something come out of the speaker. I think the owner has told me the radio worked until recently. I don't expect these tubes to die suddenly, although they could. They're much more likely to just get weaker and weaker, and you wouldn't even notice it because you're just turning the volume up higher and higher until it's just unsatisfactory. Yeah, the volume control solves a lot of ills in old radios. Okay, let's go back. I'm going to do a little camera experiment now. So, this is just the back of the radio. I was checking my cameras to see which one produces a sharper image, and I have both of them aimed at the tube tester here, which has lots of things to look at to determine which camera shoots a better image. I just wanted the most focused image. I wasn't terribly happy with how this looks. It looks a little fuzzy to me. I'm looking at it on a medium screen TV here in my shop. Let's switch cameras. Oops, I got the same camera on twice here. There we go. Let's switch to a different camera. Who's better? So I'm going to look carefully at the numbers up in here. And the markings, I can't really see that they're numbers. Oh, this guy is definitely not as good. Which one is this? I'm going to stick my finger in front of so it's this one. So it's the Microsoft Cinema camera. Slightly better. Okay, I just wanted to do that. Thought I'd share that with you. Hey, it's all part of what goes on in my shop. So I think we're going to bypass testing that tube, and hopefully we can test the next tube. What is the next tube? What is the next tube? Tube chart. EABC 80. EF89, ECH81, and ECC85. These are all kind of tubes you normally find in these radios, and EM84 for the magic eye. So they're not a problem. EABC80. We'll just work our way this way through the radio. EABC80. I have to find settings for this tube tester. I may have to switch tube testers too to do this. Okay, I've got the EABC80, which is a slightly updated version of a 6T8. This guy's got 6T8 listed, so I've dialed in 6T8. Let's just double check. 6.3 volts on the heater, 1 for the signal level, 27 L for the bias, 00076, 00076, 0153, 0153, 33 on the cheater, F. Okay, here we go. I don't know if you could see it, but I saw the pilot light flash. Okay, you can see the heater is heating. Good indications. First test is leakage or shorts inside the tube. Just watching the meter, it should not go up any significant amount. Very good. Okay, tube's ready to test. Assuming it's heated up. 780 is the reject point, so it's got to be above about here. Or this tube tester is suggesting throw it away. I don't throw away many tubes. Here we go. Okay, it's well above. Now this is a multi-part tube. So we have some diodes in here to test. I think with this tube tester you can't be turning these knobs with the tube in 03176. 03176. Bunch of zeros, all zeros. 35 on the sensitivity. Wait a minute. Wait a minute. What's happened here? Oh, okay, okay. Whew, I saw this. Never mind. It's a moment of anxiety. Unnecessary anxiety. Plate 1 and plate 2. So there's two tests here. Here we go again. Okay, give it a moment. Check it for shorts again. No. Double check very quickly. So this setting doesn't matter, this setting doesn't matter. 30076. I kind of booted this up, didn't I? What did I do? 031. You know what I did? So this chart rolled a bit. The top line that I had it set to disappeared, and then I thought, okay, this is the top line now, so I went to the next line down. Which is okay, but I'm not doing the test I thought I was doing. I'm doing the third test. That's how easy it is to make a mistake here. 03176, 03176. That's how easy it is for me to make a mistake. Make sure the plate setting's correct. Okay, we're okay. Everything's okay. So this is a diode check on the tester, if you can see it. And I don't know if you can. There's a little area here. It says diode's okay above this amount here. Okay, we'll double check again just because it's easy to do. Rectifiers and diode switch. Does it get above that spot? Oh my gosh. Okay, let's do a little. Sometimes it's just the, yeah, you know what it is? It's this. It's just not making contact in this. My poor old tube testers, I've worn them out. So it's in the diode's okay range. So I think it's okay. Now we'll do the other diode here. Double diode. 30076. 30076. P100. P100. 35. A. P100 sounds like an older man's dream, actually. Maybe I have to think about that one for a bit. Okay. Once again, looking for shorts. None found. Same thing. Diode test has to come above here. Oh. Oh, it's still warming up. Still warming up. Coming up. It's in the range. Oh, it's really going. There we are. That's a happy tube. And then B, plate number 2. That's not so good. So I have 1 weak diode in this tube. Ooh, what would that do? It's only coming up about halfway to the mark. Is it this? Is it this? Is it this? No, it's not. It's probably okay to continue using it at this point. It wouldn't explain, I don't think it would explain a dead radio. It might explain a low output or some distortion or something like that. So we have a little bit of trouble on this tube. A little bit of trouble, but not enough to explain dead radio. Okay, next tube is the IF amplifier tube. This is a very important tube. Of course, they're all important. You can't run the radio without it. EF89. I can see enough of it to know it's an EF89. Okay, gotta find the settings for an EF89. So it's always interesting stuff to read about these tubes and various substitutes that can be made, and in some cases some substitutes require a rewiring of the base wiring. But there is a direct one that's talked about, 6DA6, I remember that from the last radio I was working on. And on my tube tester it has 6DA6/EF89. That's pretty darn reassuring. So I've set it up here according to what it says on the chart. Let's check. 2. On the signal level, 34L on the bias, 05176, 05176, 0342, 0342, 34 D. Okay, we're good to go. Let's put them in. This guy, if he's bad, would be responsible for a very weak output. I don't know about no output, because we're getting nothing. When I'm tuning the AM band, there's just nothing coming through at all. That does not bode well. Let's go. There we go. Any shorts in this tube? Oh my gosh, there is. What's it doing there? It's jumping around. Jumping all over the place. So, if what's happening is the elements in here have somehow shifted and are touching now a little bit, as the tube heats up, you could imagine it would become a shaky connection like that. If a short is expected, some tubes you expect a short on certain settings here. It's listed here, but there is no warning here to expect a short. So would I dare push the test button on this? No, but what I would do is double check everything again. 6.3 volts, signal level 2, 34L. It's really these numbers that are important. 05176. 05176. Of course, it wouldn't account for a bumpy reading. 0342. 0342. Now, you get these numbers wrong and you do the short test. Sometimes you'll get a short because you've set up a short and it doesn't jump around at all. 34. Not going to matter. D. It's correct. This is slowly going away. See if I can make the tube explode here. So, yeah. So what I'm imagining is as it heats up, of course, the element is expanding. Isn't that a weird thing, really, when you think about it? You heat stuff up and it expands. I mean, like we've heard about this as kids, so we've known it all your life, so you just kind of don't pay attention to it. Things get bigger just because they're hotter. Isn't that kind of weird? Really? Okay, well, this guy's a big question mark now. You'd think something like that in the radio would cause noise, crackling and stuff. There'd be some come and go effect. So I might have to find a replacement for this one before I try running the radio again. Okay, that's a little too bad. A tube with a shorted element that was solidly shorted, that could explain a lot in terms of a radio not operating. But a shaky thing like that, that almost tells me that the problem is even further up in the radio, and that tube is not even getting exercised. ECH 81, this is the mixer tube. Okay, I gotta find out what the settings should be for that tube. Okay, good news on the testing front for this tube. And ECH 81 is right there on my chart list, the North American version, 6AJ8. So I set this up for a 6AJ8. Let's just double check. Signal level 4, 15L, I think L stands for low. 00176, 00176, 0035, 0035, 46, D. Okay, we're ready to go. Okay, any shorts in this one? Oh, I left the short setting on all the time. Look at that. What's going on there? Oh my gosh, it's the same sort of thing happening. It's not my tube tester, is it? Kind of hard to imagine how the short test would be affected by bad contacts in here, but look at that, it's gone away. It's coming back. So am I beating up the tube or my tube tester? Oh my gosh. Well, it's good right now. No, it's not. No, it's bad. It's not good. It's good sometimes. Again, if this were in the radio, you'd think you'd hear scratchy, crunchy, clicky, poppy sounds. And now it's all happy. No, it's not. Boy, am I ever unreassured by this. Okay, every time I pull out my tube tester, I go, I gotta change the tube socket or do something about it, and I never do. They don't want to run the tube test because it puts the tube tester at a bit of risk. So it's two tubes acting up in this tube tester. Both of them have North American numbers. Why don't I just grab another tube tester here and see what we can see on that. Since I have the North American numbers, I can probably use a different tube tester, an older one. Okay, so I got my Stark 966. This is one of the most common tube testers around, and believe it or not, the last tube I tested in it was an ECH 81. So I just double checked all the settings. They're good. This tube tester has its problems too with bad contact. Give it a moment. On this one, when you do the shorts test, instead of it showing on the meter, it lights up the short light bulb here. This is a neon bulb. Let's see what happens there. Okay, it doesn't look like it's heating. watch the pilot light. Yeah. Problems everywhere. Does not look like it's heating. Let's do the short test here. Oh yeah, if it flashes, it must be heated. Flashing is okay. It stays on, that's the problem. Okay, so, oh, that's right, it's a supplementary list. I have to refer to my computer here. So this first test, 1260 is the reject point. 12, so I'm on the 3000 scale. 1260 is going to be pretty much there. Oh! That's just, I don't like rejecting tubes. You can see I disconnected the heater because it started falling. It's going back up, so I got the heater connected again. That is bad. If we put it on the English setting, you read the replace and the good, you get pretty much the same reading. The idea of the English setting is it puts the reject point kind of right in the middle. And you don't have to be too smart at that point and understand numbers. 3000. Yeah, that's a dog of a tube here. Bias set to 14. This is not good here. 14, yeah. So we'll do a little sensitivity check. How important are these settings? Look, it's not making any difference really. Not gonna make it. It's not gonna get there. This English control only affects when you're on English. Replacing good. She's a dud. Now there's two more tests. Even worth doing? One more test. ED 98030. This one I don't have to pull the tube out. 980. Can't remember. So I think I can remember, but I know better than to trust my memory. 3 and then a 0 on the end. Yeah, 0 on the end. 1480. I want to do the English thing. Sorry, it's just getting confused with what I'm looking at. 2000. This is supposed to go up to 2000 now, up to here. Shorts. Okay, you see the flash, so we know it's heating. Oh my gosh, it just barely is. It's like a needle width. This is probably the reason why the radio is so dead. Because this thing is so dead. You gotta wonder, how does a tube like this get this dead? Surely to goodness, before it was this worn out, the radio had stopped working. What, did somebody just leave it on for a few more months to see what would happen? Or some grosser failure, like gas getting into it, or gas being air getting into it. Yeah, this is it's probably the heart of the matter right there on that tube. So we got one that we're not sure about and one we're pretty sure about. And the last one to check is the FM tube, the ECCC 85. Okay, I gotta get the settings for that tube tester for that tube. Okay, on this tube tester, as soon as you get these two set correctly, the filament settings, you can plug the tube in. Get it warming up. That's an efficiency move for someone who's testing many, many tubes. We'll double check what we've got here. I'm looking at a list on my computer screen for ECCC 85. Should be 76080. 76080. And then the last two settings, 11 and 85. 11 and 85 on the English. Okay, it's ready. Okay, it's flashing. This one is, this is a two tests on this tube. The first test, oh well, it's a double triodes, so it's the same target. 2580 is the throw it away point. 25, way up here. So yeah, okay. Boo. Watching the pointer to see if it's sinking also, but it's not. It's declining. The tube is still heating up. That's the only reason I can think of for why it would climb like this. I didn't let it heat up all the way. Is it going to make it all the way up here? So although the reject point might be up here, you know, it's a matter of judgment and thinking about the idea that, you know, these tubes are a little scarce, a little expensive, and just because they're weak doesn't mean you can't just turn up the volume. In many cases, it's getting up there. It's going down this time. Settling in at 2000, and let me look again at the reject point, make sure I've got it right. 2580. And a good tube would be 4100. I'd have to change the scale. Let's put on English, see what English says. Yeah, time to sell a new tube. That's what that would say back in the day. And we'll do the other half of the tube anyway. ECCC 85, EV 2103. 2103. 2103. And the last number, 0. 1185, same as the other two, 1185. Okay, short test. That seems better flashes. Not a better tube though, better half. It's going down, it's falling down a little bit. Well, that's a string of bad tubes. You know, is that something that I can expect in these kinds of radios? That strings of bad tubes? Seems to be the case. Because the last Nordmende I was doing had some sick tubes in it. Well, again, this is not dead. It's just not the most healthy. Let's see if I can do this and not drop the camera on the floor. Okay, is that my vision? Is that my vision doing that? Oh, the tube is hot. I was gripping it just a little hard here. Let me just, well, you know what, the easiest way for me to fix this situation with the camera, I've done it the hard way. I just change the other camera. Well, I'm going to put this guy back in because, again, it's not going to kill the radio. It might mean weak FM. I have a weak FM signal in a radio like this. It may come along with undesirable hiss. Because the signal level is low and the limiter stage doesn't really operate. So look at that. Look at that in there. I have two tubes that are in trouble. Can't go any further with this radio until that's resolved. So I got to try to hunt down replacements in my own tube collection, see what I got for both these tubes, and go from there. Okay, gotta go fishing for tubes.